Okay, so I'll be doing problem number 47, the red one, from chapter 4. What we're asked to find is the velocity as this block on a 15-degree inclined plane as it returns to its initial position. There's a few things given to us from the beginning. The mass of the block is 2 kilos. Gravity we know. The coefficient of kinetic friction is 0.25. The angle is 15 degrees. And the initial velocity is 2.5. And two of the equations I'll be using during this is that delta x is equal to the velocity squared, blah, 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 blah. You can read that. So the first thing that I want to know is how much this block slowed down by. And the way I do this is I find the sum of the forces in the parallel direction to the 15-degree inclined plane. So first, I want to find out how much Fg is in the parallel direction, which would be the 9.8 meters per second squared multiplied by the 2 kilos multiplied by sine 15. And that comes out to be, if I'm not mistaken, 5.07 newtons. So this is the gravity pushing. It should actually be negative. There we go. Because it's pushing the block down. Now, also there's the friction part. The friction part is the normal force multiplied by the coefficient of friction. But the normal force in this case is not gravity in the parallel direction, it's gravity in the perpendicular direction. So that's why I want to know what the force of gravity is in the perpendicular direction, because that is the same as our normal force. So again, this time, since it's normal force, we use 9.8 meters per second squared. Multiplied by the 2 kilos, multiplied by cosine 15, because now we're working in the opposite direction. And this comes out to being 18.9 newtons. Therefore, the friction part of it will be the normal force, which is 18.9 newtons, multiplied by the coefficient of friction, which is 18.9 multiplied by 0.250, which is 4.73. And in this case, now we have the friction and we have the gravity part in the parallel direction, which means we know what the force is on the block as it moves up. And if I add those together, and since this is moving down, it's also negative, so the total comes out to being negative 9.81 newtons. And if I divide that by 2, which is the mass of the block, I get the deceleration, or the negative acceleration of the block as it moves up the ramp. So I divide this by 2 kilos, and I get a number that says negative 4.9 meters per second squared. Now what do you ask me I'm going to use that for? I'm going to use it to say how long it takes the block to be slowed down to 0 as it then reverts and starts to move down to the initial position. And the way I do this is I use the initial position, which is 2.5 meters per second, and I divide that by negative 4.91 meters per second squared. And this is the numerical value of it, because I need a second number, which is 0.51 seconds. Now that is the time it takes for the block to be slowed down to 0 as it moves up the ramp. Anyway, now it's at some point up here and it's going to come back down, so now the force has changed, because now friction works in the opposite direction as it comes back down, which means that coming down, the friction force is actually added to gravity. Instead of making it 9.81, it will instead be a negative 5.07 this time plus the 4.73, which is equal to negative 0.31 newtons. And this I divide by the kilos again to get the acceleration as it moves down, which is 2 kilos, which comes out to being And with this deceleration or negative acceleration as it comes down, I will figure out just exactly how far it traveled, so I can figure out how fast it's going when it comes down. And that is when I use this equation, because that equation will tell me how far it moved. So I'm just going to write down the numbers, and we're going to get an answer. So 2.5 meters per second to begin with, multiplied by 0.51 seconds, plus 1/2 negative 4.9, which was the initial deceleration, so we know how far it moved up, meters per second squared, multiplied by 0.51 seconds squared. And this comes out to being 0.637 meters. I know it's probably crossed it. And with that, I will use this equation, to figure out how fast it's going when it comes down. So again, I'm solving for v, which I do by, this is 0, v naught is 0 as it comes back down, because we started at the point, so that's 0, this cancels out. I multiply this 2a to over here, canceling this out, and then I take the square root to cancel that out to get v. Then again, just plugging in numbers, 0.36 meters multiplied by 2 times our acceleration we figured out, which was 0. meters per second squared. All of that comes out to being 0.465 meters per second, which is our answer.